In this episode, you'll understand exactly what happens inside a wind tunnel test and why one collapsed bridge in 1940 means every bridge built today gets a model shoved into a giant wind machine before construction even starts. Before any major bridge gets built today, engineers do something interesting. They build a tiny model of it, and then they blast it with fans, on purpose. Here's why that's not overkill. It's the reason bridges have a much better success rate. Quick recap for anyone new here. In our first video, we showed how a bridge in Washington twisted itself apart in wind that wasn't even that strong. If you haven't seen that one, go watch it. It's the reason this video exists. After that collapse, engineers realized something uncomfortable. They'd been designing bridges to survive strong, straight-on wind. Nobody had tested what happens when wind hits a bridge in a way that matches its own natural wobble. So they built a system to make sure that mistake could never happen blind again. Here's the part people picture wrong. It's not just point a fan at a bridge. Engineers build a scale model, sometimes just a few feet long with the exact same proportions, weight distribution, and flexibility as the real bridge. Then they put it inside a wind tunnel and blow air across it at different speeds and different angles. They're not just checking if it survives, they're watching how it moves. If the model starts oscillating, rocking back and forth in a pattern that grows instead of settling down, that's the exact warning sign that killed the Tacoma Narrows Bridge. Engineers can catch that in a lab at model scale instead of finding out the hard way with a real bridge full of cars on it. This isn't only a bridge thing anymore either. Tall buildings get wind tunnel tested too. There's a footbridge in London, opened in 2000, that had to close within days because pedestrians walking across it in sync caused it to sway side to side, hard enough that people grabbed the railings. Not the same failure as Tacoma Narrows, but the same underlying lesson. Motion patterns matter, not just raw strength. If you've ever felt a bridge move under your feet and thought, that's probably fine, comment which one it was. I want to know. Here's my honest take. Wind tunnel testing is one of those things that's completely invisible if it works. Nobody thanks an engineer for a bridge that just stands there. That's kind of the whole problem with prevention. It's the least celebrated win in the entire field. The bridge that doesn't make the news is the actual success story. So next time you cross a big bridge and it feels rock solid, that's not an accident. That's a model of that exact bridge that sat in a wind tunnel somewhere months before construction even started. If this kind of, here's the invisible system keeping you safe is your thing, subscribe so you don't miss the next one. And drop a comment. What's the next disaster you want me to dissect? I read every one of these.